Hey guys, and welcome back to another video on the channel. In today's video we're going to be doing paper 1 multiple choice of the 2020 external exam paper for Queensland syllabus. So in this video I'll pretty much be going through the questions given on pretty much the 2020 paper, the multiple choice part. This is calculator free, and I'll be showing you my answers to them. And yeah, we'll be double checking them as we go and pretty much showing you how to get the correct answer for each of these specific questions. I will be taking my time, I won't be rushing it. So in exam conditions, you probably want to do the multiple choice as quick as possible because each of these is only worth 1 mark. However, since this is a video and I control the camera, I'm going to take my time with this one. Okay, so let's get started with question 1. So the graphs of f of x, e to the x, and g of x are shown. So straight off the back, we have to know which one's which. So we know this is f of x, and we know this is g of x. The reason why is because our exponential can't go below the x-axis, and here we know it's got solutions of x is plus 1 and x is minus 1, which we can see right here straight away. So we know that's g of x and that's f of x. So now it's asking for the shaded region between x equals 0 and 1. So that's this region here. So this is when x is 0 and this is when x is 1. Okay. So to work out this region, we need to work out what's on top and what's on bottom. So if you want this area, you need to integrate between 0 and 1 of your top function, f of x, minus your bottom function, g of x. Okay. So in turn then, we pretty much have the integral from 0 to 1 of, well, e to the x minus g of x. Now g of x is x squared minus 1. So don't forget to apply this negative to not just the x squared but the minus 1 as well. So in turn we pretty much have the integral of 0 to 1 of e to the x minus x squared plus 1. If we integrate these parts, we're going to go e to the x. If you integrate that, that stays the same. So you're going to have e to the x. Here you're going to add 1 to the power, which will be 3, divided by that new power. So you have negative x to the 3 on 3. And any constant, you just attach the variable, so plus x. So this is what we have set up, and I'm going to rub this out because I don't need this anymore. So I'm going to move this out the way. And slowly we're going to start evaluating this. Okay. So what you want to do is substitute in the first bound. So you're going to have e to the 1 minus 1 cubed on 3 plus 1. Then you're going to subtract when you sub in the second bound, so you have e to the 0 minus 0 cubed on 3 plus 0, and a huge bracket there. So if we start evaluating this, we're going to get, well, we can't evaluate e any further, so we have e minus a third plus 1. That's going to be 0, that's going to be 0. This e to the 0 is going to be 1 in itself, so you'll have minus 1. That cancels, and we get an answer of e minus a third, which we can see is D. Okay, so that's the answer for question 1. So now I'm going to rub this stuff out so I'll have room for the second question. Okay, if you have any questions about how I solved this or any further ones, leave some in the comments and I'll try and get to you as soon as I can. Okay, so question 2 is an integral, integrating e to the x plus 1 on e to the x. To start this off, I'm not going to do any fancy stuff. All I'm going to do is divide both of them by e to the x. So this is what we get. E to the x divided by e to the x is going to be 1. So 1, and then 1 divided by e to the x is still going to be 1 on e to the x. Now I'm going to change how this looks, because if you have 1 over a, that can be rewritten as a to the negative 1. So if I have 1 on e to the x, I can rewrite that as e to the negative x. So I'll erase this real quick and put e to the negative x and then attach that dx. Okay, get rid of that real quick, and now we can integrate it. So integrating 1, you're just going to get an x there, so you'll have x. Integrating this, you have to divide by the differential. So if you differentiate that inside function, you get negative 1, so you're going to have negative e to the negative x, and then since there's no bounds, you're going to add your plus c. And now we look for what answer is correct, and the answer is A. Okay, so hopefully you understood that one. If you have any questions about that, yeah, just leave some in the comments and I'll get back to you. Alright, so let's take a look at question 3 now. So question 3 I'm just going to use a u substitution. So you use a u substitution with pretty much the biggest thing you can find, the integral. So I'm going to let u equal 4x plus 6. So I need to replace this with a du, so I'm going to differentiate both sides with respect to x. So I have 4. Rearrange that, I'll have dx is equal to du on 4. So when I make this substitution, I'm going to have the integral of 2 of this whole thing will replace with u, so u cubed, and my dx will replace with a du on 4. Take that 4 out the front, so I get 2 divided by 4, which is a half, and the integral of u cubed du. Add 1 to the power, so you're going to get a half u to the 4 on 4. So you'll have u to the 4, and then don't forget a plus c as well. U to the 4 on 8, because 2 times 4 will be 8, plus c. And we remember what our u was, so our answer is going to be 4x plus 6 to the 4 on 8 plus c. Okay, so our answer for this one is D. Right? Alright, let's take a look at 4 now. I might rub this out just in case I do need the room. Righto, so question 4 is straight up I think it's a normal distribution. So pulse rates of adult men are approximately normally distributed with a mean of 10. So straight up, that's going to be your mu is 70, and your standard deviation is 8. Okay, so all I'm imagining at the moment is a normal distribution curve with my mean is 70 and my standard deviation is 8. So when I'm at 78 and when I'm at 62, that will have 68% of the data pretty much. Okay. Which of the following choices best describes the proportion of men that have a pulse greater than 78? So what that's asking pretty much is what proportion is on this side of the bell curve, because it's saying greater than 78, so you're going from this point onwards, so it's this shaded region here. So straight off the back, we've got a couple of z-scores here. Now we can actually work out the z-score, because the z-score is your data point minus your mean divided by your standard deviation. So if I had z and I plug in my data point, which is 78, so 78 minus 70 all on our standard deviation, that's going to give me a z-score of 1. So straight off the back, any z-scores that have -1 I can eliminate. So these two aren't options. Now you just got to read it. Determine the area to the left of z equals 1. So the left would be this region here, but I don't want that. I want to the right. So the answer is going to be B, because it's saying determine the area of the region z equals 1. That's my z-score equals 1. That's 78. That's what we just calculated. To the right, which is this area here. So the answer is B. Okay. If you have any questions about that, yeah, leave some in the comments, and I'll hopefully get to you. Alright, so I'm going to rub this out because I might need some room with this question here. So, as you can see, some multiple choice questions take longer than others, and we're only up to 4 at the moment. Okay, so determine the equation, the tangent to this curve at t equals 1. So to start off with, I need to work out pretty much my line. So I have y equals m. Now instead of x, they use t, so I'll use t in this case here plus c. So I need to work out what this equation is, where m is my gradient and c is my y-intercept. So we need to work out the gradient at that point there. So we need to differentiate this. So f dash of t will be differentiating this function here. So I'll put the operator there. That's pretty much just saying I'm going to differentiate this. We can see it's a function next to a function, so we're going to use the product rule. So the product rule means differentiate the first function. So if you differentiate t with respect to t, you're going to get 1 multiplied by what's left, so you have e to the t, plus leave the front function, differentiate the second, which just stays the same. So that's the derivative of this particular function here. Now we need to find the gradient at a point, so sub in t equals 1. So f dash of 1 will give you your gradient at 1, so plus 1 e to the 1. So what we're going to get is e plus e, so we're going to have 2e as our gradient, which is a bit of a weird number, but it's something you have to be comfortable with, because not all the numbers will be pretty. You'll have pi's, e's, you could have any other stuff in there. So our m in this case here is 2e, sorry. Okay, righto. Oh, nearly dropped my water real quick. Alright. Oh, sorry, I think I just banged the mic. Sorry, anyone watching. Right, so we're not done yet. We can substitute that in straight away, but we need to work out our c value. And the way we do that is with a point pretty much. Right now we only have an x value and a gradient at that x value. You need a corresponding y value in this case here, or your f of t. So what we have is pretty much, if I substitute our information, we have y equals 2et plus c. So when t equals 1, we want to know what our y is. So that means you substitute t equals 1 into this equation here. So you're going to have 1 times e to the 1. So our y value is going to be e. So this is the coordinate we're dealing with. So this means t, and this is y. Substitute that in. E equals 2e times 1 plus c. Therefore, c is going to be negative e. Therefore, my equation is y equals 2et minus e. And we can see that's right there. So that's the correct answer there. Okay? Right, let's get down to number 6. So, if the probability of success in a Bernoulli, I can't pronounce that word, Bernoulli trial is 0.3, what's the variance? Okay, so Bernoulli is very similar to a binomial thing, except your n is 1. So, if you're calculating the variance of a binomial distribution, you're going to have np1 minus p, which is pretty much the probability times the probability of failure and the number of trials. But in this scenario, we're using a Bernoulli, so your n is 1. So all you're working at is p times by 1 minus p. And now, we know what our p is. Our p is 0.3. So we're going to have 0.3 times by 1 minus 0.3. So in other words, you can have 0.3 times by 0.7. So that's going to be 0.21, and that's our answer there, D. Okay? Righto, let's get down to question 7. So, the life expectancy in years of an electric component can be represented by the probability density function below. Okay? The probability the component lasts between 1 and 10 years is A, B, C, etc. So, straight off the back, it's a probability density function, and we've given two bounds straight away. So the integral between 1 and 10 of our probability density function 1 on x squared. Now, before I even integrate, I'm going to change how this looks so it's much easier to do. So the integral between 1 and 10 of x to the negative 2 dx. Okay. Now all we got to do is add 1 to the power, divide by that new power. So we'll have x to the negative 1 divided by negative 1 between 1 and 10. Okay. So, rewriting this, I have negative 1 on x and 1 on 10. Okay? Substituting that in, I have a tenth, negative a tenth, minus 1 on 1. So, in other words, I've got 1 minus a tenth. So, the answer is 9 over 10, sorry, which is 0.9. So, the answer is C. Okay? Alright, let's take a look at 8. A test includes 6 multiple choice questions. Each question has 4 options for an answer. If the answers are guessed, the probability of getting at most 2 questions correct is represented by. So, they can't get more than 2 questions correct. That means they can get none, 1, and 2. So, straight off the back, 6 multiple choice questions. Your n is 6. This is binomial probability. And you're given 4 options. So that means the probability of getting one right is 0.25 or 1 on 4. And the probability of failure is 0.75. Now we can see those numbers appearing a lot. Now, the probability of getting none is going to be, well, for starters, it would be this expression here. Now, you can't see it. The difference between these options here is this option is saying, alright, this is the probability that I get all of the questions right except for none, 1, or 2. So that means 3 or more pretty much. And same with the one down there. So the answer is going to be B, because this is the probability of getting none right, plus the probability of getting 1 right, plus the probability of getting 2 right, which is our scenario at most getting 2 questions. So the answer is B, without even doing any calculations. Okay. Let's take a look at question 9. So question 9, I'm going to do a u sub. So let the biggest bit of our function equal u. So I'm going to let u equal x squared plus 2x. I'm going to differentiate that with respect to x because I want a du. So differentiating that, I'm going to get 2x plus 2. So now my integral is x plus 1 on, now I've substituted this bit as u, and I'm going to rearrange this, so dx is equal to, oh, I've run out of room there, sorry. So dx is du on 2x plus 2. So if I substitute the dx here, I'll have du on 2x plus 2. I can take out a factor of 2 down here, so I'll have the integral of x plus 1 on u du. Take out a factor of 2, and we can see that can cancel out with that. So what we get is the integral of a half, take that half out the front door, on 1 on u du. Integrating 1 on something is natural log, so you have a half natural log of u plus c. And when you remember what our u was this scenario here, so we're looking for a half natural log of x squared plus 2x plus c. So the answer is going to be C for question 9. Okay. All right. Let's take a look at question 10. So question 10, two types of materials A and B are being tested for their ability to withstand temperatures. A random selection of both materials was subjected to extreme temperatures, and changes were then classified according to their condition after they were removed from test facilities. The results are shown in the table. An approximate 95 confidence interval for the probability of A will break completely or show defects is given by this. Okay, so ignore all this, pretty much. That's just blah, blah, blah. We're just looking at the table. The confidence interval for material A, only look at material A, we don't care about B, it's not relevant to us, will break or show defects. So we're looking for these two numbers here. So the proportion of material A is out of 95. So that would be your proportion. So we're looking for the proportion of they completely break or show defects of material A. So the proportion is going to be 95, and then the sum of these two numbers. So 25 plus 35 is going to be 60. So I'm looking for, so my C is my proportion. So I'm looking for any ones with C. So straight off the back, I know the answer is A because I only see 160 on 95. And I don't see it anywhere else. So I know these ones are incorrect. So the correct answer is A. Okie dokie. That was the multiple choice done for methods 2020 paper, the 2020 external exam paper 1, tech free. If you enjoyed this video or you learned something or you have any questions, just leave some in the comments and I'll try my best to get back to you. But I'll be doing all the external exams previously made for methods and specialists, so stay tuned.